This is me, and I'm a math major. Everywhere I go, people ask me, why are you majoring in math? And usually my response is that, duh, because I like it, and then there are 3 follow-up sentences. Oh, I hate math. Math is useless. Math is boring. And today I'm going to answer to them. Hi, I'm Proofpilot. Welcome to my channel. I make videos about math and science. Please subscribe to my channel so I could make more to help me make more content like this. Also, like the video so other could see it too. Oh, and there's a gravitation series on the channel where I'm exploring the mathematics of general relativity. So first we have, oh, I hate math. Well, just because math is not your favorite subject or you're not good at it means that you have to blame it on me or on the math. So yeah, you were probably bullied by algebra in high school or middle school. Let's go to the second one. Math is useless. This one is interesting to me because at first I think that they're joking, right? But then I find out that they're not. So they're probably just not educated. I literally made a video about a mathematical model that tells you how to master skill. Go check it out. And beside that, if it wasn't for math, we would still be in caves and you weren't watching my video. Now, the third one, and the reason why I made this video, math is boring. And I have to say, this is why math is cool. Well, again, just because you were bullied by high school math doesn't mean that math is boring. You probably didn't have a good math teacher. And also, there is just too much bad vibe about math. For example, if I give you this type of puzzles, you quickly solve it. But when I replace the flowers and the dog with X and Y, you look like a vampire under the sun. The truth is, math problems, theorems and subjects are nothing more than a puzzle. A puzzle that came to mind of some intelligent people. It was pure curiosity, and today I'm going to show you what I mean by that. I want to talk about an interesting math theorem which demonstrates a cool concept. So go grab a map of the place you live or any map you have. Now if you have another identical but smaller map and you put it anywhere on the bigger map, there is only one point in the map which shows the exact location that the bigger map is showing. Cool, right? Well, this is called the Contraction Mapping Principle or the Banach Fixed Point. If you put the smaller map on the center of the map, it's kinda obvious where the fixed point is. But note that you can put the smaller map anywhere on the bigger map and still you get only one point, which shows the same location. Let me give you the proof of that. So this is the statement of the contraction mapping principle. Let the tuple x and d be a complete metric space and T be a contraction mapping. If you are having problem with the complete metric space, just assume that we are talking about the Euclidean space. Now, since T is a contraction mapping, then there exists a constant which the distance between the image of 2 points are smaller than the distance between the points itself, by a factor of that constant. Like what we had in our map, we choose a smaller map. Now, we claim that there exists a unique point x star which t of x star is equal to x star itself. And if you take any point x0, then do the iteration of the contraction mapping, you will get to the x star. Now let's just prove this. So we had the following assumptions. We just defined the sequence like this. xn plus 1 is equal to t of x n. We show that this defined sequence will converge to a unique point. The first step is to show that this is a Cauchy sequence. So since this is a contraction mapping, we have the following inequality. And now since this is a metric space, we use the triangle inequality iteratively and we get to the following inequalities. And the last one will get us what we need for Cauchy sequence convergence. Now since this is a complete metric space and our sequence is Cauchy, then our sequence converges to a unique point, and just by substituting we get the equality that t of x star is equal to x star. Now we only have to prove that this is unique, so let's just assume that it's not. So we have 2 points x and y that satisfy the contraction mapping principle. then the distance between them will be less than the distance between them, which is a complete nonsense, and the uniqueness is satisfied by the contradiction. So that's that, and math is cool, and as you can see, I'm not moving because animations are hard. See you in the next one. And don't forget to subscribe.